Hello children, so welcome to AIMS India's online classes. Today from mathematics subject, polynomials topic we are going to discuss. So our today's concept is regarding cubic polynomials children. So till now we have learnt about zeros of linear polynomial and quadratic polynomial. We have learned the relationship between zeros and the coefficients. Now let's see the cubic polynomials and the relation between zeros and coefficients of cubic polynomials. So let us consider this cubic polynomial. So how can we know this is a cubic polynomial? So the highest degree is 3. Here 3, 2, 1, 0. Highest power is 3. So the degree of polynomial is 3. So it's a cubic polynomial. Let it be p of x. We have a cubic polynomial p of x such that 2x cube minus 5x square minus 14x plus 8. So by substituting the values, or we can guess the values of this cubic polynomial, because already we have learned the process how to find zeros of cubic polynomial. Based on that, if you find the zeros of cubic polynomial, p of x will be 0 at x equal to 4, x equal to minus 2, x equal to 1 by 2. Means for these three values of x, p of x will become 0. P of x will become 0. So p of x can have at most 3 zeros. At most 3 zeros. And these three are the zeros of this quadratic polynomial. So let's take sum of its zeros. Sum of its zeros. 4 plus of minus 2 plus 1 by 2. 4 minus 2, 2. 2 plus 1 by 2, 5 by 2. We got 5 by 2. 5 by 2 here, 5 by 2 means here minus 5 is there. If we relate sum of zeros to the coefficients, in the coefficients we have minus 5 here. So this 5 can be written as minus of minus 5. 2, it's the x cube coefficient. So minus 5 is a coefficient of x square. 2 is coefficient of x cube. So sum of zeros is related to the formula minus of coefficient of x square by coefficient of x cube. The general form of cubic polynomial is ax cube plus bx square plus cx plus d. If this is the general form, so then sum of the zeros is in the form of minus b by a. Same like quadratic polynomial, minus b by a. Whereas if we see the product of zeros, so 4 into minus 2 into 1 by 2, 2 gets cancelled, 4 into minus 1, minus 4, where minus 4 can be written as 8 by 2, 8 by 2 or minus 8 by 2, where this constant is plus 8, we can write it as minus 8 means minus of constant term by what is to coefficient of x cube means minus d by a. For quadratic polynomial actually it was c by a, but for cubic polynomial it is in the form of minus d by a. Like this, based on this cubic polynomial, based on its zeros, we have deduced formulas for sum of zeros and product of zeros, or we have related zeros, sum of zeros and product of zeros with the coefficients of the terms of the cubic polynomial. So however, there is one more relationship is here, that is, consider the sum of the products of the zeros taken 2 at a time. Means suppose if the roots are alpha, beta, gamma, if we take the product 2 at a time, means alpha beta plus beta gamma plus alpha gamma. Like that, 2 at a time. If we take the product and do their sum, we have 4 minus 2, 1 by 2. Let's take 4 and 2 first. 4 into minus 2 and 1 by 2. Next, 4 into 1 by 2. Like that. 2 terms product and sum. So 4 into minus 2 minus 8. 2 to cancel, minus 1. 2 times 4. Here we will have 2. Minus 7. Where minus 7 can be written as minus 14 by 2. Minus 14 by 2. Minus 14 by 2. Where minus 14 is, sorry, not constant, coefficient. Spelling mistake. Coefficient of x by coefficient of x cube. Coefficient of x cube. Coefficient of x means here c. So we have c by a. C by a. C by a. So in general, if alpha, beta, gamma are the zeros of cubic polynomial, for the cubic polynomial ax cube plus bx square plus cx plus d, so then what we can conclude, sum of the zeros minus b by a, product of the zeros minus d by a, product of two roots at a time and their sum equals to c by a. Like that, we can have three relations between zeros and the coefficients of terms of cubic polynomial. Next. So here also minus b is there, here also minus d is there. Only in this case we have positive. Remaining two values we are getting minus. By a, by a, by a. Denominator part is common. Minus b by a, c by a, minus d by a. Next. So if this is the cubic polynomial with zeros alpha, beta, gamma, let us see how this alpha, beta, gamma related to ABCD. So alpha, beta, gamma are the zeros of the polynomial. So the polynomial can be written as a product of factors. X minus alpha, x minus beta, x minus gamma. Like that. It can be written as a product of factors. If we multiply and simplify, we will get x cube minus x square common, alpha plus beta plus gamma, plus x common, alpha beta plus beta gamma plus alpha gamma, minus alpha beta gamma. Like that we can write after multiplying and simplifying. So if we compare, to compare with the given polynomial, if we multiply by a, all terms, so it will become ax cube, x square, a into alpha plus beta gamma plus gamma, x into a into this one, minus a into alpha beta gamma. Or instead of a, we can take k. Instead of a, we can take k. Constant k also we can take. Constant k we can take. So minus b. So here, in the place of a, we are having k. Let's say a equal to k here. So in the place of b, we are having minus of k into alpha plus beta plus gamma. And in the place of c, we have k into alpha beta plus beta gamma plus alpha gamma. In the place of d, we have k into alpha beta gamma. That is the relation between ABCD and alpha beta gamma, where so a equal to k, and b equal to minus k into alpha plus beta plus gamma. Suppose here a is missing. If we want in terms of a also, then in the place of k we can keep a. So b equal to minus a into alpha plus beta plus gamma. C value in terms of a and alpha beta gamma. D value in terms of A and alpha, beta, gamma. Like this, we can tell the relation. So, if alpha, beta, gamma are the zeros of given cubic polynomials, find the values as given in the table. So, alpha plus beta plus gamma. What is sum of alpha, beta, gamma? What is the direct formula? Minus B by A. That equal to, what is B here? 3. Minus 3 by, what is A here? 1. So, minus 3. So, what is alpha, beta plus beta, gamma plus alpha, gamma? What is this value? C by A. What is this value? C by A. So, C by A. So, A, B, C. C value how much? Minus 1. By A value how much? 1. Minus 1 by 1? Minus 1. What is alpha, beta, gamma? Minus D by A. What is the D here? Minus 2. Minus D means minus of minus 2 by A value 1. Minus of minus 2 plus 2. Like that, directly we can find the values. So based on this, remaining 3 questions you can do as a homework, children. You can find the values. Next, children. Example 7. Verify that 3 minus 1 minus 1 by 3 are the zeros of cubic polynomial. Zeros of cubic polynomial. Zeros of cubic polynomial, p of x equal to 3x cube minus 5x square minus 11x minus 3. And then verify the relationship between zeros and coefficients. So, if we compare the given cubic polynomial with standard cubic polynomial, we get, in the place of A we have 3, in the place of B we have minus 5, in the place of C we have minus 11, in the place of D we have minus 3. So we got A, B, C, D values by comparing given cubic polynomial with standard cubic polynomial. Now P of x means, let's see, we have to check whether these are zeros of cubic polynomial or not. Let's substitute this 3 first. P of 3, 3x cube. So in the place of x, we have to keep 3 cube, minus 5x square, minus 5 into 3 square, minus 11x, minus 11 into 3, minus 3 as it is. After simplification, we are getting 0. If we substitute minus 1 also, we are getting 0. If we substitute minus 1 by 3 also, we are getting 0. So what is proved? These 3 are the given 3 values are the zeros of the cubic polynomial, because when we substitute in the cubic polynomial in the place of x, we are getting zeros in all 3 cases. So these 3 are the zeros of cubic polynomial. So these 3 are zeros of cubic polynomial. So one is alpha, one is beta, another one is gamma. Let's see the relationship. Let's verify the relationship. Alpha plus beta plus gamma equals to, so 3 plus of minus 1 plus of minus 1 by 3. How much? 5 by 3 we are getting, which can be written as minus of minus 5 by 3, where minus 5 is B, 3 is A. Means whatever value we have got while doing alpha plus beta plus gamma, it is in the form of minus B by A. So the first relationship proved. Second relationship also, if you substitute the values, minus 11 by 3 we are getting, where minus 11 is nothing but C, 3 is nothing but A. So this C by A, second relationship also proved. Third one, alpha, beta, gamma, product. If you do the product, minus of minus 3 by 3 coming, where D value minus 3, A value 3. So minus D by A. Third relationship also proved. So the given 3 values are zeros of cubic polynomial, that is proved. Along with that, the relationship between the zeros and ABCD coefficients of cubic polynomial also proved. Next one. Next concept, we have division algorithm for polynomials. Division algorithm for polynomials. So we know that cubic polynomial has at most maximum 3 zeros. More than 3, it cannot contain more than 3 zeros. So however, if you are given only 1 zero, can you find other two? Other two means we can. Suppose if this is the cubic polynomial, if we know one of its zeros, or one of its zero is 1, so then x minus 1 is a factor of given polynomial because 1 of 0 is 1. Then by dividing this cubic polynomial with x minus 1, we will get quotient. Another quotient, which is a quadratic polynomial. This quadratic polynomial, by splitting the middle term, we will get two more factors. Means we can find, with the help of two more factors, we can find two more zeros. So this one, when divided by x minus 1, this is the quotient. This quotient, by splitting the middle term, it can be written as product of x plus 1 and x minus 3. Now x minus 1 is a factor, so 1 is a root. X plus 1 is a factor, minus 1 is a root. X minus 3 is a factor, plus 3 is a root. Means if we know 1 root 1, remaining 2 roots minus 1 comma 3 we can find. Next one. So divide this cubic polynomial by x plus 2. We have a quadratic polynomial here. We have to divide it with x plus 2. So here the first term of the dividend is 2x square. First term of the divisor is x. 1x cancel. We will get quotient 2x. That quotient 2x to be written here. With that quotient, we have to multiply two terms. 2x into x, 2x square. 2x into 2 plus 4x. By changing, we have to change the signs. 2x square cancel. Plus 3x minus 4x, how much? Minus x. We can borrow next term. We can carry next term, plus 1, minus x plus 1. Now this is the dividend, this is the divisor. Dividend first term minus x, divisor first term x, means quotient will be minus 1, to be kept here minus 1. With that we have to multiply both. Minus 1 into x minus x, minus 1 into plus 2 minus 2. A plus symbol. This is cancel. Plus 1 plus 2. How much? 3. Like this we can divide a quadratic polynomial with a linear polynomial. So here the degree of dividend is 2. Degree of divisor is 1, because x power is 1, 2 x power is 0. So that's why here degree is 1. We have got constant 3 whose degree is 0. Means we can stop the division when the remainder is 0, or when the degree of remainder is less than the degree of divisor. As we got 3 whose degree is 0, less than degree of x plus 2. So we can stop the division. So this 2x minus 1 is the quotient, and this 3 is the remainder. So according to division rule, So dividend equal to divisor into quotient plus remainder. Divisor into quotient plus remainder, or quotient into divisor plus remainder. So 2x minus 1 quotient, x plus 2 divisor plus 3 remainder. If we find the value of this, so then after simplification, this will be in the form of given polynomial, which is equal to dividend, So the division rule, dividend equal to divisor into quotient plus remainder, this division rule is satisfied. So whatever answers we have got, they are correct. Next one. So divide this cubic polynomial with quadratic polynomial. So we have to write the polynomials in standard form, children. So x cube first, x square, next x term, next 0, x power 0 term, constant term. It is in order. But whereas divisor 1 plus 2x plus x square is not in order, x square to be written first, 2x power 1 to be written next, 1x power 0 to be written last, as per descending orders of powers. It should be written in this order. So dividend we take here, divisor in order we can take here. Now how to divide? In the dividend first term 3x cube, in the divisor first term x square. So after cancellation, 1 x square cancel, 1x will remain, 3x, that to be kept in the quotient. 3x to be kept in the quotient. So with the 3x, we have to multiply all. 3x into x square, 3x cube, 3x into 2x plus 6x square, 3x into 1, 3x. So 3x cube cancel, plus x square minus 6x square, minus 5x square, plus 2x minus 3x, minus x. Next term we can carry down. So now this dividend minus 5x square first term by divisor x square first term, x square cancel, coefficient is minus 5 to be kept here, minus 5. With minus 5 we have to multiply all. Minus 5 into x square minus 5x square, minus 5 into plus 2x minus 10x, minus 5 into plus 1 minus 5. After changing the symbols, minus 5x square plus 5x square cancel, minus x plus 10x equal to 9x, plus 5 equals to 10. This is the remainder whose degree is 1. Means the degree of remainder is less than degree of divisor. So we can stop the division. And we can conclude 3x minus 5 is the quotient, 9x plus 10 is the remainder. So if you multiply this one, divisor plus divisor into quotient plus remainder, if you multiply and if we simplify, we will get dividend. So dividend equal to divisor into quotient plus remainder. This is proved. So we can apply here an algorithm called Euclid's division algorithm, children, which we have learned already. So if p of x and g of x are any two polynomials with z of x is not equal to 0, means p of x by g of x, the denominator g of x is not equal to 0 for two polynomials p of x and g of x, such that there exist two more polynomials q of x and r of x. For every p of x and g of x, there exist two more polynomials q of x and r of x, such that p of x equal to g of x into q of x plus r of x. or dividend equal to divisor into quotient plus remainder. So where remainder r of x is either equal to 0 or degree of r of x is less than or equal to degree of g of x, means divisor. When if r of x is not equal to 0, then degree of r of x will be less than degree of g of x. That is the condition for this Euclid's division algorithm. This is known as Euclid's division algorithm for polynomials. Means for every p of x and g of x, there exists q of x and r of x satisfying this rule. Next children. Now we have the following results children from whatever above discussions we have done. Based on that, we have the following results. If q of x is a linear polynomial, then r of x, remainder r, will be a constant. Because if we are dividing with a linear polynomial, then remainder will be either constant, either 0, or degree less than divisor, means here degree is 1. Less than 1 means 0. X power 0 means which is a constant. So that is one conclusion. If degree of q of x is 1, quotient. If degree of quotient is 1, degree of p of x, dividend equal to 1 plus degree of g of x. 1 plus degree of g of x. 1 plus degree of g of x. Means so the dividend p of x, divisor g of x, quotient q of x, remainder r of x. Now what is the condition here? If degree of q of x is equal to 1, if the degree of this is 1, so then degree of p of x equal to 1 plus degree of g of x. 1 plus degree of g of x. Means if this is a linear polynomial, degree of dividend equal to 1 greater than degree of the divisor. Degree of divisor. Next, if p of x is divided by x minus a, then the remainder is p of a, which we have learnt already. If remainder r equal to 0, so then q of x, we can tell q of x divides p of x exactly, or q of x is a factor of p of x. Q of x is a factor of p of x. Next one. Next one, example 10. So divide this cubic polynomial, because here degree is 3. It is not in order, but highest degree power is 3. It's a cubic polynomial. Divide this cubic polynomial by this quadratic polynomial and verify the division algorithm. So the given polynomials are not in standard form. They have to be written in standard form. After that, to be divided. So after division, like we have done in previous examples, after division, the remainder is 3. The quotient is x minus 2. The divisor is this one. This is the dividend. So remainder, dividend, quotient, divisor. So now, let's check the division algorithm. Dividend equal to divisor into quotient plus remainder. If we substitute the values, if we multiply the values, it is equal to the dividend. So division algorithm is verified. Like that we can tell. find all zeros of this biquadratic polynomial, because highest degree is 4. Biquadratic polynomial, if you know that two of its zeros are root 2 and minus root 2. Biquadratic means it will be having 4 roots. Out of 4 roots, 2 roots are given. We have to find 2 more roots. Since 2 zeros are, one is root 2, another is minus root 2. So therefore, we can divide this biquadratic polynomial with x minus root 2, x plus root 2, or the product of x minus root 2 and x plus root 2. So means x square minus 2. We can divide it with x square minus 2, because these two are the zeros of a given polynomial. Then x minus root 2 and x plus root 2 will be the factors of given polynomial. So the given polynomial can be divided by product of the factors, x square minus 2. So here, dividend, first term 2x power 4, divisor, first term x square. So from x power 4, x square cancel means x square will remain. So 2x square, let's keep it in the quotient, 2x square into x square, 2x power 4. X term is missing here. So this x cube term will be missing here. Leave it blank. 2x square into 2, 4x square. To be written under x square term exactly. Now symbols change. Minus plus, this cancel. Minus 3x cube. Minus 3x square plus 4x square plus x square. We can carry next two terms down. So now minus 3x cube first term by here first term x square. From x cube, x square will get cancelled. 1x will remain, minus 3x. Let's multiply with minus 3x. Minus 3x into x square, minus 3x cube. Minus 3x into 2, plus 6x. So x cube term is there, x square term is there, x square term is missing. Let's carry it as it is. X square, this cancel, minus 2, this also cancel. X square minus 2. Now here, first term x square. In the divisor also, first term x square. Cancel. The quotient is 1. To be kept here, plus 1. With 1, if you multiply, x square minus 2 will come. Minus plus, we can do cancellation. 0 we will get. So now this is the dividend is a product of divisor into quotient plus remainder. So quotient, divisor plus remainder. Remainder is 0. So that's why no need to mention. So here x square minus 2 is there. X square minus 2 means it's a combination of x plus root 2 and x minus root 2. The two roots already we know. For finding 2 more roots, whatever remaining factor is there, we have to split the middle term such that the product is equal to last 2 terms. So we can write it as 2x square minus 2x minus x plus 1. Then the product of middle terms equal to product of a and c. Yes, it is equal. Now we can take 2x common, x minus 1. We can take minus 1 common, x minus 1. Again x minus 1 common, 2x minus 1. So if x minus 1 is 0, x equal to 1. If 2x minus 1 equal to 0, x equal to 1 by 2. So along with root 2 and minus root 2, we have 2 more zeros, 1 and 1 by 2. Like that we can find the zeros alone. Okay children, that's all for today. So thank you for watching our video children. Please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website children, www.aimstoday.in. for other information. Thank you, children. Have a good day.